All right, so section 1.2 is continue dive into your geometry terms that you should kind of have already in your mind. So we have angle relationships and similar triangles, and we're going to talk about geometric properties and triangles. Clicking it is under. Okay, vertical angles. So vertical angles have equal measures. Do y'all remember what a vertical angle is? Does that look familiar from geometry? Hopefully it does. Vertical angle are when you have two lines that intersect, and they meet at a point. They share the vertex. Okay, the vertical angles are going to share the vertex, and that means opposite angles are going to be congruent. Okay. So in the case of here, we know that angle NMP equals angle RMQ. We also know that angle NMQ equals angle PMR because they are opposite angles. So opposite angles are going to be equal measures. Okay, that's vertical angles. Parallel lines. Parallel lines are lines that never intersect, correct? When you have parallel lines cut by a transversal, does this look familiar? Does that word ring a little bit of a bell? Transversal. When you have parallel lines cut by transversals, it creates other angle inequalities, okay? Same side interior, alternate interior. Yeah, those words, they're back. I know, okay? So that's what we're gonna be talking about is what are those relationships and how does that look? Parallel lines and transversals. So we're gonna first start here with our alternate interior angles, okay? Your alternate interior angles are when you have two parallel lines cut by a transversal, and the angles on the inside are going to be equal. So in this case, we would say angle 4 and 5 are alternate interior. So therefore, the measure of angle 4 equals the measure of angle 5. The same rule applies to alternate exterior angles. They're the angles that are on the outside of the parallel lines on opposite sides of each other. Your geometry notes. Okay, so we would say that the measure of angle 1 equals the measure of angle 8. Does anyone remember the rule for same side before we get there?
One of them minus 180.
Yeah, so they're what? The S word. Supplementary, okay? Alternates are gonna be the ones that are equal. Same side are gonna be supplementary. Let me know when y'all are good for me to go to that. Okay. All right, so when we have our same side angles, they're going to, same side interior, same side exterior, they're going to be your supplementary angles. So notice here, we have same side interior. Our interior angles here. So we know the measure of angle 4 plus the measure of angle 6 has to equal 180 degrees. Corresponding means that they're on the same side of the transversal, either above or below the parallel lines. So angle 2 and angle 6 are corresponding because they're both on the right side and they're both above the parallel lines. So they're corresponding angles. And corresponding angles are going to be equal measured. So we would say that the measure of angle 2 equals the measure of angle 6. Yay, geometry. Okay, you guys spent probably a good 2 weeks doing this. We do not. We spend today and tomorrow, and that's it. So, just keeping that in mind. That's why I just want to emphasize. Okay, so how does knowing this help us? Well, it's how we find unknowns. Knowing the rules and making the connection between those angles helps us solve things we don't know. So up first, it says find the measures of angles 1, 2, 3, and 4, given the lines M and N are parallel. Okay. So the first thing we have to determine is what is the relationship between angle 1 and angle 4? So angle 1 and angle 4 are what? What are they called? Alternate exterior. They are alt exterior. Okay. Because they're alternate exterior, what does that mean their relationship is? They're equal. We know that the measure of angle 1 equals the measure of angle 4. Correct? So therefore, I'm going to take their two unknowns and set them equal to each other. So we have 3x plus 2 equals 5x minus 40. And then now it becomes an algebra problem, right? It's no longer geometry, it's now algebra. So we're going to do the algebra to get our x by itself. So we're going to subtract 5x, subtract 2, and we're left with negative 2x equals negative 42. So therefore, x equals 21. So can I find the measures of my angles now? Yes, because we know what x is. So we're going to find measure of angle 1 and measure of angle 4. So we have 3 times 21 plus 2. What does that equal? We get 65. So we know that the measure of angle 1, which equals the measure of angle 4, which also equals what? Yeah, but what else? What other angle also equals 1 and 4? 3. This also equals the measure of angle 3 is going to be 65 degrees. And why do we know 3? It's a vertical, right? It's a vertical, or it's also corresponding. Okay, and then therefore, what is the measure of angle 2? And that's because we 180 minus 65, which gives us that's how you apply all the relationships. That's why I call geometry the English of math. It's way more words, not like.
And again, that was 4 years ago. So.
All right. Yes. Ready to go again? Or not? All right. We're going to angle sum of a triangle. Angle sum of a triangle. So angle sum means if you add up all 3 angles, they must equal what? 180. So if I know 1 or I can know 2, I can then always solve for the other, right? Because they all have to equal 180. So, bam, find the measure of the missing angle. You got this. I believe in you. All right, so first thing we should do is just either add 48 plus 61. 48 plus 61 is going to give us 109. Second, we're going to do 180 minus 109, and we get 71. Bam, there's our missing angle. Ta-da! Angle sum. Yeah. All right, let's keep going with triangles. Okay, so classifying your triangles. We have 3 types of triangles. You have an acute triangle, a right triangle, and an obtuse triangle. When we're talking about the angles, okay? So if you're classifying by angles, these are your classifications. This is not classifying by size, this is classifying by angles, okay? So angles, acute triangle means all the little angles are cute little tiny triangles less than 90, right? A right triangle means you have one right angle, and an obtuse means you have an obese angle up in there, okay? Obtuse angle. Got it? Next, classifying by their sides. You're describing the relationship between the sides. If all sides are equal, we call that a equilateral triangle, right? If 2 sides are equal, we call that an isosceles triangle. And if no sides are equal, we call that a scalene triangle. I'm going to give you all a random fact about this problem right here. So in 7th grade, I took the Duke Scholastic test or whatever that made you do, take the SAT or whatever in 7th grade. I had to go to high school, sit in class with a bunch of high school students and take the actual SAT. And there was a question on there about scalene. And I was like, I literally had like a panic attack because I could not remember what the word scalene meant. So like to this day, when I see scalene, it takes me back to sitting there, taking the SAT, sitting in this high school, surrounded by high school students, not remembering what the heck the word meant. And yeah, one of those core memories that haunts me. But anyways, scalene triangle. No sides are equal. I will never forget that. Okay, so conditions for triangles. For triangle ABCD similar to triangle DEF, the following conditions must hold. Do we remember things like angle, angle, side?
Yes.
Oh,
Side, angle, side? That's what we're talking about, okay? So corresponding angles must have the same measure. Corresponding sides must be proportional, okay? So that's what we're leading into are those things. All right. So when we're talking about determining whether they are, we have to think, do they have angle, angle, side congruency? Do they have side, angle, side congruency? Can I say that these 2 triangles are equal to each other? Okay. All right. So in the case of these triangles, they are marked by the angles. Do we see this angle is equal to that angle? That angle is equal to that angle. That angle is equal to that angle. That is angle, angle, angle congruency, right? AAA. Triple A congruency. Because of that, I can then say that these 2 triangles are similar. Yes? And because they're similar, then therefore everything has to be equal. So stating what's congruent, let's find the measures of angles B and C. So angle B is going to be similar to what? M. So therefore the measure of angle B equals what? And that is 31 degrees. Okay. C, so angle C is similar to who? To angle P. Therefore, the measure of angle C equals 104 degrees. And I can state this because of angle, angle congruency. Yes? No one's like, we never learned this in geometry. Otherwise, there was a whole 6 weeks of your geometry that I'm questioning what took place in geometry. If you did not do this, I don't know what happened there. All right, so looking at this again, what type of similarity do we have again? Based on our markings? Based on the markings is angle, 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 right? And so therefore these 2 triangles are similar. Because they are similar, that means that there's a ratio between its sides. Does that ring a bell? Okay, so if I'm looking for the side measurements, as long as I know similar sides, I can then state from there. I know that side CA is similar to side ED. Agreed? So they have a ratio of 16/8. What is that ratio? 2. So my ratio is 2. So I'm dividing each side by 2. It's a factor of 2. So can I find the other measurement, other sides? So therefore, the measure of side EF is what? 16. And that's because it's half of CB. Agree? The measure of side DF equals 12, and that's because it's half of AB. Yes? How do we feel? Yes. Leave it. All right. Next. Same thing here. All right triangles. For right triangles, their congruency is different, right? That's because it already has a congruent angle. And therefore, as long as you know the measurement of size, they are generally proportional to each other because of that angle. Okay. So workers here, it says, workers must measure the heights of a building flagpole. They find that at the instant when the shadow of the station is 18 meters long, the shadow of the flagpole is 27 meters long. The building is 10 meters high. Find the height of the flagpole. Can I find a correlation between those two? Yes. Do you remember what we set up? Starts with a P. A proportion. We set up a proportion. So we're setting up a proportion. This is our unknown. This is all of our known, right? So we know that the height of the building is 10. Its shadow is 18. We do not know the height of the pole, but we do know its shadow is 27. And how do you solve a proportion? Cross multiply, and we get 10 times 27 equals 18 times x. After we cross multiply, then we're going to divide. So calculator people, how tall is the flag? $15 meters high. They are literally doing this right now in geometry. I printed out the worksheet yesterday. All right, yes. Are we good? We're still okay? Cool. That is it. 1.2.
Oh, yeah.